4.3 homework number 21. Find the derivative of the function y equals quantity 2x to the fourth minus 6x squared plus 8 to the fourth power. They use the notation this time dy dx, which means the derivative of this function y with respect to x. We could also write it as y prime. It means the same thing. Now in this case, we have a differentiable base, and by that I mean that we don't have a straight power rule because we have a function inside that has a derivative. So the chain rule says that if y equals f of x to a power, it's going to be the power times the base, which is the entire function, to the power minus 1 times the derivative of whatever that base is. So you're not finished when you do the power rule. You have to go one step farther, take the derivative of what is inside there. So if I have y equals 2x to the fourth minus 6x squared plus 8, all raised to the fourth, my dy dx, my derivative of y with respect to x, is the power times this whole polynomial base to the power minus 1. Now I have to take the derivative of that base, 8x to the third minus 12x. So I use the power rule on those first two terms. So sometimes these can be simplified a little bit, but this one should be fine just like this. 2x to the fourth minus 6x to the second plus 8. That's all to the third power. And then 8x to the third minus 12x. So number 22, s of t equals 41 7t cubed minus 5 raised to the 5/4. So this time I'm going to use the power rule again, s prime of t, so my 41 constant is there, times the power, 5/4, times the base, 7t cubed minus 5, times the power minus 1. I'm going to go ahead and write that 4 over 4 so that I can do my common denominator, times the derivative of the base, 21t squared. Now I'm going to get these monomial and constant factors into the front. So 41 over 1 times 5 over 4 times 21 over 1t squared times 7t cubed minus 5 to the 1/4. So we're going to simplify a little bit simply because we may need it later to be more simplified. So I'm going to take my calculator out. 41 times 5 times 21 is 4,305 over 4 t squared times 7t cubed minus 5 to the 1/4 power. Again, you'll have to gauge what my math lab will accept. It will come a time when you have to simplify in order to solve certain problems. Number 23. So this time we have a function that has a square root. We're going to rewrite our square root. With a 1/2 power. Then we're going to follow the chain rule. Power times the base to the power minus 1, and I'm going to write it 2 over 2 because that's a common denominator, times the derivative of the base, 18x. I'm going to collect my constant factors and my monomial factor, the 18x, into the front, and then I'm going to reduce my exponent. 1/2 minus 2/2 is negative 1/2. I'm going to take out my calculator and go 6 times 18 divided by 2. So 54x over the square root of 9x squared plus 3. You see what I did here? This negative exponent moves this base to the bottom, and a 1/2 exponent means a square root. Like I said, you may be able to get away with less simplification. You can play around with that. I am not going to count off if you don't simplify. However, if you need to simplify for application problems, it's best to practice it on every problem as much as you can. Number 24. Find the derivative of y equals 5x plus 1 to the third times 3x plus 2 to the negative 5. They're using the notation dy over dx, which means the derivative of y with respect to the variable x. We have a couple of options here. This is a product, so we may use the product rule, right? So if y is f of x times g of x, y prime is the first one times the derivative of the second one. So that's f of x times g prime of x plus the second one times the derivative of the first one. In each case, the base is differentiable. I can take the derivative of 5x plus 1. I can take the derivative of 3x plus 2. So for that reason, I have to apply the chain rule whenever I take the derivative of each one of these powers. So dy dx, using their notation, the first function, 5x plus 1 cubed times a negative 5, the base, 3x plus 2, reduce the power by 1, negative 6, be careful, not negative 4, that would be adding 1. And then here's the tricky part for the chain rule, times 3. I've got to remember to take the derivative of that base. Power times the base times the derivative of the base. Plus the second one, times the derivative of the first one. 3 is a power. 5x plus 1. Reduce the power by 1. That makes it a 2. Derivative of what's inside there is a 5. Now, my math lab may take it just like this, but my preference is for you to go ahead and simplify it at least a little bit. So for the first one, I've got a negative 5 and a 3. That's a negative 15. 5x plus 1 to the third over 3x plus 2 to the sixth. Negative exponent, base goes on the denominator. Plus, this time I have a 5 and a 3, 15. 5x plus 1 squared over 3x plus 2 to the fifth. So again, negative exponent, this base goes to the denominator, becomes a positive 5. Now, I could get a common denominator and add these, but I don't think I have to, so right now I'm going to leave it like this. So I've got a negative 15 and a 5x plus 1 to the third over 3x plus 2 to the sixth plus another fraction, 15, 5x plus 1 to the second, and 3x plus 2 to the fifth. Check my answer, and they took it in that form. You can play around with seeing what they will take, and I will take it if my math lab will take it. Again, I warn you, there will come a time when you do have to do some simplifying, but hopefully at those times it won't be quite as complicated as some of these are. Number 25, find the derivative of the following function, y equals negative 4 over 9x cubed plus 5 to the sixth. Now, you could use the quotient rule here. When you take the derivative of the numerator, you're going to get a negative. But instead, I'm going to write this as a negative exponent, 9x to the third plus 5 to the negative 6. And now I can just use the power rule, remembering I have to take the derivative of what is inside because what is inside has a derivative. So the negative 4 was there already. The power is negative 6. The base to the power minus 1, be really careful, that's going to be a minus 7. All of that is going to be times a 27x to the second because that's the derivative of 9x cubed. I'm going to simplify this a little bit. I've got a 24 and I've got a 27x squared and I've got a 9x cubed plus 5 to the seventh in the denominator. And then all I need to do is 24 times 27, 648 x squared over 9x cubed plus 5 to the seventh. So my numerator is 648x to the second. My denominator is, in parentheses, 9x to the third plus 5 to the seventh.